Hello guys, this is Engineer Vakas Ahmed. Once again, I am going to present very conceptual, dynamic, industry-based video in which I am going to explain about oil and gas EPC projects, that how these projects are going to start from very beginning level, and we are going to split different phases within design, documentation. There are feed, there are pre-feed, detail engineering design, procurement, different kind of models, what kind of documentation you require to understand these concepts as a project planning control. If you want to get good fit in Gulf region in oil and gas sector, this video is going to play a very vital and important role. So stay tuned till end of today's video. I'm going to present. So before starting this video, I would request you people to subscribe this channel so that in future if I make any kind of video, you can get that link on time. Well, my name is Engineer Vakas Ahmed and I have spent 15 years in the field as a project planning and control engineer on mega oil and gas Gulf region based projects. So today's video is purely based on industry based learning, and I would call it oil and gas EPC project. So let's start what I'm going to present in today's video. So step by step, we are going to have feasibility study, because every project, if you talk about your pipeline construction projects, oil and gas project, petrochemical, refineries, any project, it is going to start with feasibility studies. Then conceptual design is the second step. Then pre-feed, front end engineering design. Then feed, front end engineering design. Then I'm going to explain detailed engineering design. Then procurement and fabrication. Then structural works or construction works. Then installations. So how we need to understand all of these phases as a planning engineer. The process I'm going to explain as per Gulf region industry, as per oil and gas project, is going to play a very important role in your concept building. So let's start with our first task, that is project life cycle. Before getting into the detail, this concept is very important, which I have specifically designed for you people. This slide is about project life cycle so that you can summarize all of these phases. You can keep this concept, visualize this concept, then we can get into the details of each and everything. So first of all, the application of project management, we are going to divide it into the different kind of processes, like initiate phase, there is planning phase, there is execution phase, there is a monitor and control phase, and same there is closing phase. Five process groups we have there. So within initiate phase, we are going to start with feasibility, then conceptual design, then pre-feed, then basic design or feed, detailed. Within this feed, we are intended to prepare these documents like design packages. Like within these feed, we are intended to prepare 10% cost analysis, like there is some buffer of 10% to prove feasibility. Then basis for bidding, because these are EPC projects, so right after feed we are supposed to bid these project to EPC developer. So this document is also going to serve as a bidding document as well. Then project award, bidding stage, ITT or ITB, invitation to tender or invitation to bid. Then within planning phase, this EPC developer is going to make these detailed designs with 30% model, 60% model, 90% model. 30% model means the long lead items will be procured at 30% completion of that design. 60% design will be completed, and then planning of procurement for the bulk items will be started, and 90% designing will be completed. Then finishing items like cable trays, electric boards, distribution boards will be started to procure, and then alignment of these design milestones with procurement will be done within planning phase. Project schedule will be started by these EPC developer with this milestone. Project schedule will be comprised of scope baseline. They are going to maintain their project WBS, major milestones. Then schedule baseline are going to develop critical path method. Cost baseline are project funding requirements. We can call them S curves or cash flows. and then resource requirement plans, manpower, material, and machinery. So all these milestones are work milestones will be done within planning phase. Then within execution phase, construction or installation will be started, and within monitoring and control phase, there is a complete project management technique will be conducted, which we call earned value management analysis. And this is very important for reporting as well, right? So then the fifth process group is closing. Within closing, like either you have got your 100% project done, then it's handing over. If your project is not completed yet, then you have to go into the revising scheduling, like delay analysis and claims management, or you can call it EOT, claim for extra time to complete that remaining percentage of your work, right? So in within closing phase, you are going to do that one. So I hope you can visualize all of these milestones in very effective way, right? That what lies inside initiate phase, what is inside the planning phase, monitoring, control, then closing, then execution, each and everything. Now we are going to see this slide with another perspective, like level 1 schedule, because as a planning engineer there are different kind of categories of project schedules, like level 1, the feasibility, or you can carry this level 1 schedule until conceptual design pre-feed, in which your higher level milestones are involved, right? Very higher level information, like engineering phase, how much time it is going to consume, how much cost of the project, like 10%, like 15%, then same planning for procurement phase, then construction phase, right? So that is called level 1 planning. Then level 2 and level 3 planning is done at the feed documentation level, or you can say tender documentation. At this level, you can also call it tender scheduling. So at this level, you are going to add more details. You are going to define your WBS, right? In the, like in engineering, there are structural drawings, there are MEP drawings, there are piping drawings. In procurement, you are going to guide that as per the specifications, your vendors are going to provide those items within how much time window, right? Within construction, how much many milestones are there, how many foundations you are going to build, right? Because in feed many things are visible now, right? So that is why there is 10% cost buffer, right? After that, this project will be awarded, and level 4 plan will be awarded at the project schedule milestone within planning phase. This level 4 is fully loaded, like critical path method is there, resources are there, your each and everything is there. Schedule baseline, time baseline, scope baseline, resources baseline, cost baseline, everything is there. So that is why we call it level 4 planning, or you can call it another name is baseline schedule. But baseline schedule will be categorized as level 4 if and only if there are resources are loaded there, right? And then recovery schedule means if your project is not going as per your project KPIs, like indicators, SPI, earned value management indicators are going to show that your project is detracked or your project is going on track. If there is too much progress lag, then your client is going to ask you that we need to revise or recover that schedule. There is a minute difference between this recovery schedule and revised schedule. Within recovery schedule, you don't disturb that completion date. You are only going to make your project compression techniques like fast tracking and crashing, and you can make your re-strategize your remaining work within remaining time, right? You are going to implement these strategies. But closing phase is going to help you to start with your EOT. That mean by revising scheduling. Your completion date will be disturbed. Maybe you will need extra 2 months, 3 months, 6 months on the available conditions based. So that is all of the things you are going to conduct. There are major milestones, there are different kind of schedules demand, and different milestone, recovery schedule, revised schedule, and this slide can help you to understand the further detail which I'm going to discuss with you people step by step. So from onward, I will be sharing with you people the very basic thing, feasibility study. Whenever any project is going to start, you can imagine like pipeline construction project, building construction, any oil and gas projects, right? So feasibility, what does mean by feasibility? Everything starts with a simple question: is this project even worth building, right? Any client, government authorities are going to think like that way. So the question is going to develop that feasibility. You are going to start with your experts to develop that report. So this report is where investors, owners, and governments decide if the project makes economic and technical sense, right? In oil and gas, you study the route, environmental impact, terrain, and demand. If you are going to make consideration of all of these factors. And example, is it better to transport crude oil via pipeline or by ship, right? Is it, this is called alternative analysis, which kind of option is more feasible for me, money saving, time saving, technical oriented, like I'm feasible with this kind of technology, or another technological alternative is more feasible to conduct the same thing, right? So, in airport planning, your estimate passenger growth after few years, regional demand and infrastructure feasibility, something like that. Maybe can this city handle 20 million passengers a year by 2035, right? So such kind of questions, such kind of analysis, market analysis are going to develop your feasibility study. This phase involve cost benefit analysis, site selection, and budget forecasting. All of you viewers, I would request you people to memorize these major important points, like at feasibility level this 30% cost buffer is there. Like if you are going to analyze that, like let's say this airport is going to take $100 million, might be possible when you are going to arrive on detailed engineering design it can take 130 million or 70 million. There can be a buffer of 30% threshold, you can say. And the other thing, site selection is involved in this feasibility, budget forecasting, cost benefit analysis is there. So conclusion of this feasibility study, which experts are going to conduct, that is market analysis and cost benefit analysis. These are the two major milestones you need to study. You need to conduct study and make your conclusions. If these are green signal, then great. The second big milestone is technical viability. I have already explained you people the selection of technology, the route analysis. If I'm going to construct a pipeline, so which route is most suitable, economical, technically feasible for me? So all of these things are going under this case study, which we call feasibility. And approval for next stage, the conclusion will lead towards the next stage, like concept study, conceptual design, that is the next stage, are shelved for time being. Our management can decide, our government authorities can decide, we can take it into the consideration later on after 2 years, after 3 years. That does mean by shelved and rejected, we are not going for this concept or for this feasibility or for this project. So in case we are getting approval, then the next stage is called conceptual design. So conceptual design phase is the first technical step after the feasible study. The purpose is to develop and define the project concept just enough to evaluate cost, compare options for what kind of technology we are going to select, and support early decisions before moving into feed, final investment decisions, FID. FID, final investment decision, is also going to consider in this phase. And within this conceptual design phase, the key objectives which I want to convey you people: define project purpose and scope. Let's say you are going to construct pipeline construction project, so it is going to involve that what is the purpose of the construction of this pipeline, or this refinery, this petrochemical industry, this transmission line project, this electrical grid station project, right? This building construction project, and what kind of major level scope of work is involved, right? This conceptual design. And then identify site location where we are going to construct this project: south of Dammam, east of Abu Dhabi, or north of London, right? And pipeline route, initial block flow or process flow diagrams, PFD, that how it will look like. The process flow diagram, you can see that the layout, that when if you talk about any refinery, these are the boilers, the reactors, the piping is going like this one, then from here there, this is called block flow diagram or PFD. What kind of equipment would be there, and the process integration of any petrochemical or oil and gas refinery or any oil and gas production unit project. So then higher level cost estimates, obviously at this level you are going to make that 30% cost level buffer is over there, that your cost analysis or cost estimation can give you the range of 30% precision, right? And within this you are also going to select major system and technology options, what kind of boilers, reactors, heat exchangers, separators, tanks, piping, which dia you are going to use within this project. Then compare multiple technical alternatives, what kind of technology I'm going to use. Like for a building, maybe there is a step footing, there is a raft foundation, any other abutment footing, if there is a bridge, how much depth for the pile going to be considered at this level. If pipeline construction project, what kind of dia I can go for that one, it should be undergrounded, above the ground. And what kind of flow meters I should go for, what kind of IT technology we should go for, what kind of infrastructure. So there are multiple alternative analysis should be documented within this report for better decision making. Provide input to the board of directors. Obviously this all documentation will be forward to the board of directors for go or no go decision. And key deliverables for conceptual design, objective, scope, and boundaries, that is going to define your project concept statement. Process flow diagrams, that is one document you are going to compile. Block flow diagram, the one document which is going to help those people. So anybody going to ask you that what are the documents you are going to prepare at the end of conceptual design. So these are the preliminary equipment list, initial cost estimates, site layout or route map, and preliminary environmental review, right? So all of these documents are going to make concept design package. On the basis of this, you are going to forward this package to board of directors, and they are going to give you the decision go or no go, right? So examples I'm going to quote again, so better understanding you can carry. And here you can see that in this example it is much clear. Like if there is pipeline construction project, so okay, this much length we require from this terminal to this terminal, piping dia maybe this one, or we can go for this technology, this much pressure, this much flow rate, carbon steel is the material we are going to construct that piping. Pumping stations 5 6, hilly terrain, one river crossing, two population zones, this is one route, another route should be there, like which can help us to take a better decision. Korean mitigation, initial plan, internal coating, cathodic protection, and same you can see that this much cost estimation, uh, cost incur for this project construction at this level. So that is an example which we are going to put up in our conceptual design to the board of directors for the next stage, right? So why we need this conceptual design? Do you want understand? It determines whether the project proceed to feed, right? At this level, every previous stage, like in this scenario, the next stage is coming is feed. So previous stage is conceptual design. So conceptual design is going to give us a green signal, right? Then it identifies the major risk. So to control risk, if we are going to make our homework in the previous stage, it is more better, it is more productive, it is more strategic to control that certain risk in the next stage if we have already prepared for that one. It influences cost class and financial model as well. It allows technical comparison of alternative routes. Obviously that is why we because these are all the job interview kind of questions as well. People are going to ask you with different kind of analogy of those questions, like why we need it, what are kind of documentations we are having in that conceptual design, right? And how we can prepare that kind of documentation. And then it gives confidence to stakeholder and investor to invest in that certain project. So after that conceptual design, the next stage is pre-feed. Before getting into the feed, there is still a lot of work we need to do, which is called pre-feed, front end engineering design. So, what is pre-feed? Obviously, pre-feed is something before getting into the detailed feed. Front end engineering design is the intermediate stage between conceptual design and feed, where high level technical definitions, project boundaries, and execution strategies are prepared in more detail. Okay, so what are those details? It ensure that the feed phase starts with a clear scope, because you know that our feed document will also serve as package for the EPC developer bidding, right? So we need to make more focus, more detail, more accuracy. So clear scope is the first requirement, and realistic assumptions. We can't say, okay, if it happens, then we can do that one. No, no, no. You have to go for realistic assumptions, that what this project is carrying. The project oriented specified assumptions, right? So here you have to make filter out the things. Purpose of pre-feed in oil and gas projects: confirm the preferred concept. In this specific stage, you are going to take the technology selection, concept, route map, alternative analysis. Multiple options are there, but you are going to choose one of those options. Then define the design basis and technical limits, thresholds, design criteria, right? The specifications, API standards, something like that. Conduct initial technical and commercial risk studies, that is also involved in this pre-feed. Prepare preliminary execution strategies. Like in pre-feed, you are going to define on the basis of your project available conditions, as per the conceptual design availability of data. You are going to define, okay, our project is going for EPC or EPCM. EPC, engineering, procurement, construction, EPCM, engineering, procurement, construction, and management. There are many other models as well. You can watch my other videos as well, because in those videos I have explained these things in very details as well, because there I have more focus on these different kind of models. Here I'm going to share with you from basic to advanced level how the process is going to be in the details, right? So preliminary execution strategies like EPC, EPCM will also be the part of this phase, pre-feed, and establish the budget range and cost class, like how much you can make for this project. Secure stakeholder and board approval. They are going to make you final approval before getting into the feed. At every single stage, your board of directors, your senior management, your project directors, authorities are going to make decision, uh, green signal to get into the next stage. So here we are. What is feed? The main phase, which is called front end engineering design. Feed is a critical engineering phase that bridges conceptual design and detailed engineering design. If you can see that right now, this is our conceptual design, this is our feed, and this is our detailed engineering design. So it is actually bridging these two. This is your feed, front end engineering design, and this is conceptual design, and this one is detailed engineering design. You understand? So what is feed about? It defines the technical scope, performance requirements, and cost framework to move forward confidently toward execution. And I would be explaining here technical scope, like pipings, like fabrication, tank, all of these things technical. What kind of technology we are going to use? Performance requirement, like resource requirements, like design requirements, cost framework, funding, project funding requirements. So these are the major milestones. As soon as we are getting closer to the execution, our financial model, our execution model, our resource requirement model will be more blatant and more visible and more easy to understand and more in the details, right? With more accuracy. Feed is also often used as the basis for EPC tendering and project financing, right? That is what I have already told you. In job interviews, they are going to ask you. So this is important thing, that this feed document, on the basis of this document, you are going to hire EPC developer, right? At this stage, you are going to hire the contractor or EPC developer. And then objectives of feed phase. Here, define the project scope in technical and commercial terms. finalize process and equipment design at preliminary level, like what process we are going to conduct as per the petrochemical industry process, refinery, production houses, whatever. So your equipment threshold, like pressure bearing ratios, if there is a pipeline, how much psi pressure they are going to bear, right? So that's what you are going to mention. Refine cost estimates. Now whatever cost is going to be concluded, that should be within the buffer 10% up and down, right? There should not be 30%. Now it should be more accurate, more close to the accuracy. Then generate tender document for EPC bidding. From this feed document, you are going to generate EPC bidding document for cost, for scope, for calculation of piping, for PFD, and each and everything. Confirm project viability before committing full resources. You are going to present these much resources you require and how you are going to conduct that project, the execution strategy. So before full commitment, because EPC is carrying full risk on the shoulder of the contractor or EPC developer after bidding. So you have to be very much clear about it. And after this, input required for the feed phase, obviously whatever you are going to prepare, what kind of input documents you require to complete this package, feed document package, approved conceptual design package, design basis document, project feasibility data, site selection layout. Already you have get approval from conceptual design and pre-feed, right? So now these documents will serve as inputs for feed: initial capacity, utility, routing, alignment from the corridor surveys, and key deliverables. On the basis of these inputs you are going to prepare. So one by one, process flow diagrams. Now this process flow diagram will be more in the details, that what kind of equipment, how much would be the length of piping, at which stage I need gate valve, at which stage I need PSV, PCV, heat exchanger, foundations, building, trenching. So this process flow diagram is going to show equipment listing, line list, many more other things will be part of this process flow diagram as well, right? Piping and instrumentation diagrams, and then process simulation and calculation diagrams, equipment list and data sheets, line list, instrument list, preliminary plot plans and site layouts, hazardous area classification drawings, fire zone safety layouts, preliminary procurement plans, work breakdown structure of your project, level 1 and level 2 schedules, or you can call it tender scheduling, right? I have already explained this thing in my project life cycle. And then risk management plan, and then cost estimates class 3 at that level, and then tender package for EPC bidding. All of these things are going to be part of your bidding process. All of these things, like process flow diagram, each and everything. Your process engineers, your designers, your estimators, your process control engineers, your maintenance people, your operation people, they are going to help a planning engineer to prepare that data, and then they are respectively going to make these process flow diagrams, PNIDs, and then calculation MTOs will be done, and prepare your MTO sheets. On the basis of those sheets, you are going to analyze that how much scope of work will be done in future. So this will serve as EPC bidding process, right? So these are the key deliverables. And then target milestones. Obviously, these are the target milestones, but finalization of technical design basis. This is the finalization. Completion of major PFD and PNIDs. And then approval of plot plans and space allocations. Submission of feed cost estimate with 10% precision. Issue of EPC tender documents, and gate review or board approval for EPC phase. Why we call it gate? Because at this is milestone. This is phase milestone. At this stage, you can revise the things. You can see if there is any error, you can revise that. So this is a major milestone. That is why we call it gate review. Transition handover to detailed engineering, because after this process of feed, approval of feed document, you are going to bid for the EPC developers. You can offer them a final document that this is our scope of work. On the basis of this cost evaluation, we are going to invite you to participate in this EPC bidding, right? So at the same time, right after this award of the project, the EPC developer will be starting their detailed engineering design. So in other words, this is the transition from feed into the detailed engineering design, right? So this is called, in oil and gas pipeline project, it includes pipeline. Like I'm going to give you an example. Like if you are pipeline material or any project, you can assume as per your case study, as per your current project example, pipeline material selection and sizing will be documented in this feed. That is the intent of this phase. Route alignment sheet finalization, through which route we are going to construct this pipeline. Station, how many stations, how many pumps, how many major areas or configurations we are going to require. Initial control and automation strategy, right? SCADA system, data collection systems, and all that. Flow assurance and corrosion study, that would be done in, because that would be started from very initial state, feasibility to conceptual design to pre-feed. But here there is big details involved specific to our project. Then environmental impact of this pipeline construction project, if there is any environmental refineries there, we can make a report, HSE report, hazard report, that how it is going to impact on our environment. So these are the major targets. So summary notes. Feed is often 50% of the process engineering work. It provides the foundation for detailed design and construction. A strong feed reduces risk, delays, and cost overruns, right? A good compiled feed document can reduce your risk. You can identify your risk before it's going to happen, and you can prepare your mitigation plan, plan A and plan B, kind of that. Fee deliverables are often marked as approval for design or detailed design. Like if it is going to approve, then it will be issued for detailed design, right? So guys, after this feed phase, we are going to dive into bidding process, and we need to take overview that how this phase is gonna happen. As long as it concerns with our project planning and scheduling engineers, we need to understand the documentation, the procedure, and the process understanding. So here, once the feed front end engineering design is complete, the client initiate the tender or bidding procedure to invite qualified contractors. Like you can see that the first of all there was feasibility, then conceptual design, then pre-feed, then feed. Now after feed, the outcome, the documentation would serve as a package for EPC bidding. So now this client, either it can be ADNOC, Aramco, PDO, Qatar Energy, OGDCL, ONGC, any oil and gas client or any other EPC client, is going to invite different kind of EPC developer from market to participate in that bidding procedure. And the documents on the basis of which this bidding is going to happen are fee documents, right? So key steps in the bidding procedure, that is majorly you need to understand. Issue for tender package, we can call this stage ITT, invitation to tender or invitation to bid as well, but we can call it post feed. And it includes actually the feed drawings, PFD, PNID, layout, constructional drawings, technical specifications, bill of quantities, preliminary construction schedules, right? The tender schedules. Here I just want to shed a light on this thing. Here at this stage of EPC bidding, on the basis of feed documents, we are going to understand the schedule which is going to be part of this bidding procedure is tender schedule, which would be level 1 or level 2, having very higher level information. But in most cases, because feed is actually having 10% cost buffer, so it would be most detailed one as well. On the basis of these milestones, the further schedule will be derived. So WBS and preliminary cost estimates will also be part of this package. General and special contract conditions, that on the basis of this project, how this project will be executed, what are the specific conditions would be preferred during the execution of this project, payment methods, if there is some design revisions, if there is some MTU kind of things, performance based margins and all that, site oriented specifications, land acquisitions, all of these things are specified to the project. So that is why this document is also included, all of these documents. I would say over here that as a planning engineer, if you are watching this video, so these all the milestones you need to memorize, that as for your job interview preparation, and for the planning and scheduling step by step proceedings. And then project execution strategy, what kind of technology you are going to adopt, what kind of construction methodology you are going to take up. So all of these things will be narrated in this planning or bidding package, right? So construction point of view, from contractor bid preparation, the contractor who will be invited to participate in this bidding procedure based on these documents, which will be handed over to this multiple EPC developers or contractors. So they are going to review and interpret feed documents. They are going to see, okay, this is layout of piping, isometric drawings, fabrication drawing, construction drawings on the basis of feed package, and they are going to review with their expert people and identification of design gaps or assumptions, right? And they are going to make cost estimates as per their understanding in the terms of material calculations, labor requirement, equipment or non-labor, or machinery requirement, or subcontractor requirement. Then they are also going to identify that what kind of risk they are going to encounter while doing this work. Contingency plans, like plan A is not valid, then what will be the risk management mitigation, or plan B, right? That is called contingency or reserve kind of things, like extra time, extra money in case of any risk happening. A commercial proposal, markup, profit margins, indirect cost, like what kind of supportive teams they need to be on having on site or during that project. So they need to include all of these things. And technical and commercial evaluation, client evaluates contractor bid based on, because multiple contractors are going to participate in that bidding procedure, so compliance with the feed scope. So client is going to see that which one of the EPC developer having more feasibility, having more technical viability, compliance with that feed package, right? So on the basis of that one, they are going to evaluate one of the contractor. Technical competency, obviously they are going to see that what kind of project they have been doing in the past. Execution capability, the same thing, the performance capability, proposed cost and delivery plan. Obviously they are going to see that what will be their project delivery method and how they are going to execute. Historical performance, the same thing, what they have been doing in the historical data. They are going to check that previous project they have been doing the same projects, and it's going to be their first time, or they are having experience of in joint venture as well, right? So negotiation and award, after this all clarification, value engineering discussions, like there are meetings, they are going to give the opportunity to all those people. Might be possible in some cases they are going to give site visits as well, right? And value engineering discussions will make them more clarify final adjustment in scope and terms. There are kickoff meetings, so they are going to discuss about the things, if there are any gaps, there are any technical kind of things they need to discuss. Then contract signing and project award is going to happen over there. So project delivery method selection, now this is the major thing which is going to happen actually before award of this project. But here I just want to make sure that you need to understand there are different kind of project delivery methods, like EPC, EPCI and DBO. I'm going to discuss one by one. That EPC, engineering, procurement, construction, it means you are after feed, you are given that project on the basis of your feed package, and then you will be responsible as an EPC developer to prepare your engineering phase, your detailed engineering design, your procurement, like buying phase as well, and the construction phase as well, right? So full scope delivery, this is one, design, buy, build, used for oil and gas facility, pipeline, and the single point responsibility. All the risk is on the shoulder of contractor or EPC developer. And a crude oil pipeline from station A to B with pump station and SCADA is awarded to one EPC contractor based on feed package. This is just an example that such kind of project can be having the EPC delivery method in construction. And then we are having EPCI. It is going to add one more phase, installation. Majority phases, EPCI contract delivery method would be adopted in offshore oil and gas projects where fabrication will be done, but all that equipment, tanks, heat exchangers, all those oil and gas project equipments are going to be transported on offshore site area, and only they need to be installed there, commissioned there. So preferred in offshore oil and gas projects, example subsea pipeline with risers and subsea manifolds, contractor must fabricate and install modules offshore, right? DBO. Here you are not only build, buy, design, build and buy, but also to maintain. O&M is also the part of this project contract, right? Operations. Suited for the public partnership projects are utilities where revenue is performed linked. Contractor operates the facility for 10 to 20 years. They are not only getting rid from the project after completion of construction installation. It's not like that, like earlier contract delivery method like EPC, EPCI. In DBO, you will be responsible to maintain for the operation phase for 1 year, for 2 years. It depends on the contract nature. Some of you people might have seen BOT projects as well, build, operate, and transfer, the same kind of nature of projects. So, example, wastewater treatment plant. So a contractor who is given that project, that is responsible designing, buying the material, then construction, and after this construction they are going to commission. They are not going to hand over, they are going to operate in the, they are going to revenue, generate the revenue. Now what is the insight in this operation to be managed by contractor, to just not compromise on the quality of the equipment during their execution phase. So that is also very promising kind of contract delivery method. So how contractors evaluate the feed package? So they are going to, as per earlier statement, they are going to see feed package, all drawings and all of these things, validate technical scope. They are going to in those meetings they are going to fill those gaps, technical scope, design completeness, ambiguities, right? Match estimated quantities with BOQs, evaluate constructability and risk, align internal cost benchmark with feed scope, cost estimates, identify long lead items. That is what I'm going to align now, that how designing, procurement, and construction is going to align with each other. So as of now, during the bidding phase, the contractor is going to take everything into the consideration, that this construction will be based on these parameters. So they are going to marginalize everything, like calculation of manpower, requirement of equipment, machinery, materials, and on the basis of that, they are going to calculate risk, and they are going to add up everything, right? So what contractors submit in their bids? Technical proposal, design approach, resources, commercial bids on the basis of previous slide, execution schedule, right? They, at this stage they are going to submit their level 1, level 2, whatever HSE plan, list of vendors, subcontractors, and all that, right? So real world example, oil and gas pipeline project, client, let's say National Oil Company. The post feed scope of work is 220 kilometers onshore pipeline, 3 pumping stations, SCADA system. Delivery mode chosen EPC. Contractor bid includes engineering hours based on feed specifications, piping material cost based on MTOs, scheduling aligned with monsoon constraints, right? Like monsoon rainy season is there, there is a big risk, right? 6 months procurement, long lead time for control valves, $10 million contingency for route clearance and stakeholder issue. I mean, like all of these things will be part of our project bidding and all that, right? So final milestone after bidding. Once the contract is awarded, final scope and pricing are frozen, right? Now nobody can change that scope, that cost. You understand? That should be your pinpoint. EPC project is fixed cost and fixed time oriented project. Detail engineering begins. Now, the detail engineering design is going to start right after this project is gonna award. Then, procurement of long lead item is triggered. That is what I'm going to share with you people. There are different kind of models, 30%, 60%, and 90%. and then baseline schedule is established for execution phase as well. Now planning engineer are going to start on the basis of available data like detail engineering design, their procurement, material requisitions, procurement buying models, then construction models, and they are going to match up all the phases with each other within that completion date, start date and finish date, and they are going to establish that critical path method on the basis of available resources, construction methodology. So planning engineer is going to start their own work. So detail design phase is going to start from here. This is the phase where all engineering discipline translate the feed package into construction ready document. Now that feed document, which was already the part of our bidding package, now on the basis of that package, all of that process flow diagram, process instrumentation diagrams, foundational construction drawings, fabrication drawings, we are going to detail the design. Not we, only EPC developer, because he is the responsible to make this detailed design. Okay. And input documents for detailed design, no other words but all the feed documents, but again on the basis of here process flow diagrams, approved ones. That's what I have already narrated. All of these things, equipment data sheets, design basis documents, plot plans, site layouts, preliminary hazardous area classifications, field level cost estimates, and WBS, which was part of our bid document. Again and again, I will repeat you people that I will suggest you one assignment, you people. Just make block diagram. This block is going to represent your feasibility. Next block is going to represent your conceptual design. Then next block is going to represent pre-feed, then feed, then invitation to tender. Then there are different kind of branches that what contractor is going to evaluate, what kind of document they are going to be given, right? The procedure, how they are going to marginalize their cost, risk, resources, right? What are the important documents? And then after award of that project, how they are going to get into the detailed design. So here detailed design inputs are there. Okay. So risk register is there. Risk, the initial level risk which were identified by client and consultant itself. Now they are going to make those risk register as an input for the detailed design, and then vendor recommendations as well. So procurement and execution strategy as well, the feed package document will be serving as a input of our detailed engineering design. So now detailed engineering design will carry output documents which are like we are going to have approval for construction or approved for construction drawings in the details, because on the basis of these drawings we are going to start our civil works, structural works, architectural, mechanical, piping, isometric. All of these drawings will be prepared as a output of our detailed engineering design. Then final equipment list tagged and coded, like material takeoffs will be done out of from these detailed engineering drawings, right? Quantities will be estimated, and updated specification with vendor data, that who is going to provide or supply those materials or services. Then construction work packages, like we are going to define our construction work packages which are going to serve as our scheduling WBS as well. So pre-commissioning procedures, interface management documents, that how we are going to make scheduling, procurement and construction interface on our project scheduling. Updated hazard reports. Hazard is actually hazard and operability report which is going to assess risk, right? And it is going to be also defined into the our conceptual design at initial level. Then feed is going to give more detail to this report, that how or what kind of risk or issues would be there if we concern about our operations, our works during this execution works, right? Identification of risk, right? So then procurement requisitions for balance of plant items, right? So all of these things would be the outcome of detailed engineering design. We will also take all of these documents, but these are the byproducts like MTOs, construction work packages, pre-commissioning procedures, procurement requisitions, right? Construction method statement as well will be submitted by this our EPC developer. And the detailed design and scheduling alignment. Now, that is the point where I just want to take your attention as a planning scheduling expert. If you are going to start understanding all of this procedure, that how these all things should be aligned, because now you have all of the concept that how things are going to push the previous phase is going to push the next, and what kind of things are involved in that specific package. But here, alignment, the dependency, I repeat again, the dependency is very important for every planning engineer, scheduling engineer for oil and gas projects. And I can show you all of these things on Primavera P6 as well. Right now, you can see that we have over here, if I can show you, these are the design phase, feasibility report, conceptual design. So, this is on Primavera P6, the complete package, conceptual design, feed, and then we have EPC package, ITT, like invitation to tender, then detailed engineering drawings, then your procurement, long lead items. So what kind of tool we are going to use to document everything, to integrate our complete project from very starting level to the execution level, to the handing over level. So Primavera P6 is going to serve you as a tool, and the people who are going to understand the Primavera P6 features with this concept, with complete understanding of field oriented process, field oriented documentation, they will be act like a planning engineer. At a junior level, they will be like schedulers, but or schedulers, but with the process of this all understanding the concepts, they will be like a planning engineer, right? So I would request you people, if you want to take such kind of training, oil and gas project training, EPC, construction planning and control training using Primavera P6, you can participate. I will also link up there a 2 hours video which is going to help you in further details the complete schedule development. And in a part of that tutorial, if you want to take my online training, my complete project planning control training on EPC planning projects, on shutdown projects, on delay analysis, you can contact with my team and you can also participate. So getting back to the topic, detailed design and scheduling alignment, this is called dependency model. In Primavera P6, I have given you that insight already. Now I'm going to share with you that detailed design is starting after feed, and it is getting this is, I'm going to share again in Primavera P6. This is our feed. Okay, you can see over here, if I can make relationships, it's another thing. Like if feasibility is going to be done, then in relationships we can go over here and I can make, I repeat again, if you want to understand this software, there is a free course 2 hours tutorial I have put up on my this YouTube channel, and I will link that on earlier my notification as well. You can just click and you can start that one after watching this video. So in that video I have explained this thing, that how to make this logic, like feasibility report will be done and then conceptual design will be started. And once conceptual design will be done, and then you can see that I want to remove this one and my feed is going to be started. That is actually dependency model, right? That is, we need to understand, feed is done, then only in then EPC, ITT, this is going to be done. Once this done, in only in that situation my contractor or EPC developer is going to submit all of these document, construction methodology and all that. Once all of these things are done, then our detailed designing is going to be started, or you can link this with the approval of feed, assign, and detailed designing will be started, like structural drawings. Okay, like all the designing packages, the detailed designing, the mechanical design will be started, the piping drawings will be started. These are the predecessors, successors, these are the dependent activities. And then the procurement phase, this detailed design will be driving the procurement phase, which is given over here. All the procurement items will be conducted through MTO, material takeoff exercise. That what kind of, there are two kind of procurement items, bulk items and long lead items. So I'm going to explain that one as well. So here you can understand discipline wise 30%, 60%, and 90% model reviews. This is very important for understanding when you are going to start your design. This is your designing activity, right? So when your design is complete, like 30%, you are going to start procurement for long lead items which are going to take extra time, high cost, like turbines, like pumps, which need design specifications to manufacture. The items which are going to take extra time, maybe more than 3 months, these items can impact on your project schedule. So we need to start their procurement on very early stage. When design is going to be like, we are not going to wait for complete design completion. We are only waiting for 30% design. Specifications are set over there by designers, and we are having the knowledge of quantities. We are going to start procurement, because in procurement there is a complete procedure. You have to advertise, like, right, ordering. There is a complete phase of ordering, there is a complete phase of manufacturing, and then delivery. And these three phases need very caring shortlisting, because if something is going wrong, it is going to impact on your project schedule. Ultimately it is going to become a risk and going to impact on your project cost, right? So long, that is why we need only 30% design completion, right? And then once it is 60% completed, we are going to start our project procurement for bulk items, the items which are easily available in market, and like steel, like electric boards, electric cables, something like that. And then 90%, if design is completing, we are going to make order for finishing items, like the items which we need at the late stage of our project construction, like doors, furnitures, like asphalt in road construction, or you can identify. And you also the items which need for the finishing are miscellaneous items, right? So that is how it is going to make dependent disciplines. That is how it is going to make the linkage, right? And then drawing submission milestones, obviously. And then equipment procurement milestones, has up review completion, obviously, that report first construction work package issued to construction, end of detailed design, transition to construction phase. Impact on procurement of long lead items. Long lead equipment like compressors, pump, valves, instrumentation, and transformers must be identified and released early in detailed design. That is what I mentioned, 30%. When design is 30% is done, then you are going to identify and start procurement of all of these items. Delay in detail specifications, vendor approval, or IFC document leads to delay in fabrication. Obviously, your previous phase is delayed, your next phase is automatically going to delay, and ultimately going to impact on your project cost, and it is going to become a float reduction. What does mean by float? It's another thing. Again, I will suggest you that video, so that you people can understand. Float is actually a flexibility. Whenever we are going to start our project, complete integration plan, there is design, procurement, construction, there are multiple paths. So one of those paths is going to be called as longest path, which is going to be having critical path. All the other paths having flexibility, amount of time, which is called float. So project milestone slippage means if your project is detracked, if your project is not on as per your plan, so that is called project milestone slippage. So if something is delayed in the procurement phase, it is going to delay in your construction phase as well. So planners must build interdependency logic. That is very important thing. That is what I wanted to convey you people, right? So design is going to drive your procurement, and procurement is going to make that item available on the site area or workshop area, and then you are going to start that construction. So lessons for project planners are over here. Detailed design phase is the last control point before site execution. Every deliverable has downstream cost and time impact. Rebaselining must happen before this phase closes. Integrate detailed design progress into earned value management analysis. Yes, because that is ultimately your monitoring and controlling phase. And prepare weekly, monthly S curves. These are all part of your project scheduling by products. Here I'm going to just share with you people all of those things, that 30% model identification, the same thing I have mentioned earlier, that these are the long lead items, right? These are the procedures you are going to make first of all, identification of those items which you need to make procurement at 30% stage. Those would be like long lead items, and requisition issued to the vendors, to the suppliers, to the the third parties, bid evaluation, all those parties are going to submit you offers. Okay, on the basis of these specifications we are going to provide you services or materials. So bid evaluation, you are going to receive those bids and going to start evaluate technically and commercial interest as well. Purchase order issue will be done on the basis of their shortlisting. One of the supplier will be shortlisted and awarded that purchase order issue, right? Vendor documentation will be given to you and you are going to give approval. Fabrication, and the same thing, they are going to fabricate that thing, and same thing I'm going to share over here. And you can see in the procurement, this is your ordering, this is your manufacturing, float inquiry, receive bids. This is the complete procedure which you are going to conduct to shortlist one of the supplier, one of the vendor. Then they are going to start manufacturing your items, and these are the procedures involved, and final inspection and then delivery. And then this procurement item will be linked with that construction activity, right, on which that tank sheet is will be available. That is going to make interdependent of your project, right? So logistic and delivery and all that. Procurement of long lead items, what are LLIs, which are going to take extra time, more than maybe 2 months or 3 months, and going to impact on your project. There are different kind of features like heavy cost, big impact on your project schedules, like this way, right? And custom manufacturing. Procurement by design progress level, you can see 30% model. Again, I have already shared with you people that compressor, turbines, pumps, all these items will be procured at the 30% model review. Okay, and you can see that one. These are the proceedings, the activities I have shown you in Primavera P6. This is 60% model. All the bulk item materials will be started, carbon steel, stainless steel, alloy, all these pipings will be started or under the umbrella of bulk items. All these cable trays, secondary steel structure, instrumentation devices, standard valves, motor control, these will be started, procurement will be started for these items when 60% design is done. Then 90% model review is for the finishing items, right? Remaining E&I cables, lighting, small power system, terminal blocks, earthing materials, HVAC, painting, insulation, consumable, and these are based on finalized layout and all that. So fabrication with vendor. Now, this procurement is transition into the fabrication. Fabrication with vendor, they are going to start fabrication with schedule using Primavera P6 with procurement logic, right? Design approvals. That's what I have already shared with you, in the Primavera P6 dashboard. Now I will be sharing with this thing over here. You can see on Primavera P6 how it will happen for you people. Just give me a moment. Here you can see block diagram. If I can show you, this is our block diagram. See, this is our feasibility, feed, conceptual design, feed. This is our bidding and so on. See, detailed design. You can see that every single phase is going to link up with everything. This is called interdependency. Every project phase is interlinked with each other. Now I'm going to share with you people over here like how it is going to work on here. So here, just to summarize this one, that was your, you can see the first one, feasibility. Feasibility is going to drive your this one. The second phase is your conceptual design. Conceptual design is going to drive your pre-feed. Pre-feed is going to drive your feed. Feed is going to drive your ITT or award of that project. Then detailed engineering design. Then on the basis of this detailed engineering design, there are 30% model, 60% model. 30% model is going to start your long lead items, right? 60% model is going to start your you can see bulk items available, procurement, and 90% model is going to make your availability of your resources of your finishing items. And then your construction phase is going to start it, right? Like from here, yeah, fabrication. Once fabrication is done, then your, there are two kind of works are going to happen. Such kind of diagram you need to make by yourself. This is your construction phase. One is the fabrication through procurement, and one is the civil works. So that is how they are aligning with each other. Like this one is going. This is dependency model, the generalized one, right? So you can also write, make this one like this is detailed design over here. So this is 30%, 30% model, 60% model, 90% model, and then construction phase is going to be started as per the notice to proceed, and then your procurement will be available. Like this item should be available. If there is an activity over here, then this should be available like this one. Then this something like that. So there, these are all the construction schedule. Like I will be showing here, over here. You can see right now. This is your complete. See, I will be showing you people, and right now you can see this delivery on site, this item. I will be giving you an example. This tank float inquiry will be derived by the item. This activity is coming by the dependency of, you can see over here, see, float inquiry. You can start, if you can go to, and you can see that once this tank design, see, this is actually bulk item, so 60% approval is like 60% design is done. So from here this will be started, and then you can see over here float inquiry. I can go to, your procurement is going to be started. Now delivery on site, and go to, these are the fabrications. Fabrication will be done for the tank, bottom loop rings, shell plate rings, and rooftop rings, right? This is another knowledge, right? If you want to understand all of these things in details with proper specifications, understanding of construction projects, oil and gas projects, you must enroll in my comprehensive live online training sessions, in which I'm not only giving you this project planning, Primavera P6, but process oriented understanding that how oil and gas projects will be developed, executed, and controlled. And there are shutdown projects, there are EPC projects, there complete EOT, delay analysis and claims management. There are 3 courses I'm offering: EPC planning control using Primavera P6, shutdown management using Primavera P6, and delay analysis and claims management using Primavera P6. And here you can see that erection, installation will be done on the basis, these are the civil works as well. See, these are the foundations of pipe racks for storage tanks. Backfill will be linked with the concept. So this is complete interdependent project. That is how everything is depending on the another thing. So complete understanding of this phasing of EPC project, EPCI, EPCIC, DBO, right? These are the contract delivery methods. So I would invite you people in my training. I would request you people to share this video link with your fellows to enhance their knowledge, as well as write down in the comment area about Primavera P6 file. I will be sharing this XZR file with you people as well, so that you can, at the initial stage, you can understand by yourself, you can develop your interest. There are many job opportunities out there, and by understanding this concept, there is one good news for you people: you can get easily job in Gulf region, in US based market, in UK, Australia, Canada. There are much freelancing projects over there, building roads and oil and gas project, many more freelancing projects. And if you want to make your way to Gulf region like Abu Dhabi, Saudi Arabia, Qatar, Oman, job based career, this is much more easy for you people, because companies need planning engineers with proper skills and all that. Join my upcoming session. I hope you are going to learn many things. Thank you very much.